Hello, folks. We are starting our first Blue Level lesson. If you are watching this, that means you have chosen to do this. This is not necessary. It's only for those of you that feel the need to challenge yourselves further. So, again, if you're watching this, it's a choice. So, if this wasn't the choice, go ahead and hang up. Okay, now, Blue Level. What does that mean? So it means that right now you're not feeling challenged by the work that I gave you, or you're trying to prepare further for next year's classes or possibly even college courses. And I'm going to be giving you new and fresh ideas and new and fresh skills that eventually are really going to come in handy. Very important. Okay, so what are we going to talk about today? We're going to continue talking about solving one-step equations, but we're going to throw in an extra wrench, which is fractions. Okay, so I have a couple of examples here with adding and subtracting fractions. Okay, so our first problem here, we notice that we have a variable added to a fraction, and we want to solve this. Solving equations means isolating the variable. To isolate this variable, we need to get rid of this fraction. You'll notice that this fraction is positive, so therefore we need to subtract it to get it to the other side. Subtract 11 over 10. And if you do something on one side, you got to do it to the other. Subtract 11 over 10. But we'll notice that when we're adding and subtracting fractions, we need to have a common denominator. That means the same denominator. So I'm going to look at this 8 over 5 real quick, and I'm going to do a little bit of work to get that. So we can't subtract it. 8 over 5, we want a common denominator of 10, so we're going to multiply by 2 to get this 10. Much like doing the same thing on both sides of an equation, if you multiply by 2 in the denominator, the lower portion, you need to multiply by 2 in the numerator, which gives us 16 over 10. These are equivalent, the exact same fraction, but now if we rewrite this as 16 over 10, we now have 16 minus 11 tenths, which gives us 5 tenths. So n is equal to 5 tenths. We canceled out this, leaving only n on this side. N equals 5 tenths. Ignore this blue line over here. Just 5 tenths. Okay. Now, looking at another example, over here we have a subtracted, this is really x minus 5 over 3 equals negative 47 over 30. When you add a negative, it's the same as subtracting. And if it's subtracting, we need to add the 5/3, add 5/3 to both sides, add 5/3. And this is actually an easy one to get a common denominator. We're going to pick the bigger common denominator, just like we did over here, and we're just going to add a 0. Multiply by 10, multiply by 10. And 50 over 30 is the same as 5/3. Now, this cancels out, leaving us with just x equals, and we have negative 47 over 30 plus 50 over 30 is equal to 3 over 30. Now, are we done? No, you should always leave your answers in simplest form. And hopefully we notice 3 and 30 can be simplified to 1 over 10. 1 over 10. And we have isolated our variable, therefore this is solved and simplified. 1 over 10, sorry for the messy handwriting. Now, that was for multiplying and dividing, but now what if we have situations where we have to, or sorry, that was addition, subtraction, this is multiplying and dividing. Now, there are a lot of ways to handle this. I'm going to show you what I think is the simplest way. First, we need to start off with an example. I'm going to make up a fraction, 5 over 7, okay? Now, in order to make this fraction equal to 1, I'm going to multiply by 7 over 5. We call this the reciprocal. It just means that you flip the fraction. Now, if we multiply across, that's how we multiply fraction. You multiply the numerators and multiply the denominators. 5 times 7 is 35. 7 times 5 is 35. 35 divided by 35 is just 1. Now, why is this important? Why is this multiplying by the reciprocal important? Now, for this right here, we want to get k by itself. Now, in order to get rid of this fraction, which is what we need to do to isolate k, we need to get rid of this fraction. We can, the easiest way is to multiply by negative 12 over 19. The negatives become positive. The reciprocal times the reciprocal becomes 1. If you do it to one side, you got to do it to the other, multiplied by 12 over 19. Okay, and all of this cancels out with all of this, leaving just k on this side of the equation. Now, if before we move on and multiply 19 times 12, I have no idea what 19 times 12 is, and I don't expect you to know that. But we can simplify first. We have negatives, a negative and a negative. That makes a positive. Those are gone. 19 in a numerator times 19 in a denominator, they both can cancel out, which makes this much simpler. Now we have 12 over 9. Are we done? No, we're not done. We noticed that there is a factor of 3 in both 12 and 9, so this can be simplified further to k equals 4 thirds. This is a perfectly acceptable answer. I do not, in very few situations do I expect you to make it a proper, a mixed number. You don't need a mixed number, it's not necessary, okay? Now, using the same policy over here, I'm going to multiply by negative 3 halves and multiply by negative 3 halves. This leaves just n over here. Cancels out, cancels out. And here, we can simplify early. Instead of bringing it down, we can notice that 33 and 3 have a common denominator, a common factor of 3. So I divided both those by 3. 16 and 2 have a common factor of 2, which leaves 8 right here. And look at that. We don't need to simplify any further. That's as simple as it goes. We also could have done that over here with the 12 and the 9 early, but I wanted to show you both versions of it. Results in the same thing. Okay. Now, folks, I have left you with a worksheet in Google Classroom, which, if you choose to, you can complete and email to me. If you send me an email with a picture of your work, I'll look through your work, let you know how you're doing, and most importantly, congratulate you, because you are going above and beyond to make sure that you're learning as much as possible. Just because you're at home doesn't mean that's not an option, right? You can always email me with any questions. And again, I'm proud of you, your family's proud of you, and your school's proud of you. Well done, okay? Have a great day, and take care of yourselves.